For many of our legacy products and tools, we would not know who's using them, how they're using them, when they're using them. And the roadmaps were kind of being driven by the hippo effect, the highest paid person in the room making the decisions.
That is what we're targeting, to use analog neuromorphic core, the system where data processed directly from analog sensor and in analog format without digitalization.
What AI and software does is, based on the specific application demand, you can tailor which sound you actually want to pass through your communication channel and let people hear.
Education is key. Yeah, you need to know how to do it to avoid problems. You said startups before, but also big companies can fail on lack of knowledge.
Welcome to Forging the Future, and I'm here today with Jason Griffin, and he is the Managing Director of Software Product Experience for Analog Devices. Welcome to the show.
Hi, Chris. Thanks for having me. Great to be here.
Always nice to talk to an engineer, too. Yeah.
Engineer at heart. Worked many roles in analog devices, but more in management side now, but the engineer is always there in me, yes.
I always think about it. Every time you get promoted on the management track, I feel like you get a lobotomy.
Yeah.
You do less and less technical stuff. But,
yes, absolutely. And that's what you really aim to be going back towards quite a lot. And it becomes part of your personal life then. How can I get more into the engineering side?
Exactly. Sure. Well, tell me a little bit about analog devices. It sounds analog, and of course we're in a very digital world. What does analog devices do? Yeah, so analog devices is at the pillar of the semiconductor industry for almost 60 years now. In fact, this coming year will be our 60th year. Oh, congrats.
Yeah. And, our chairman is still involved in the company, he's still part of the board of directors. But Analog Devices has been world renowned for our data conversion, signal processing, as well as our power products. But, if you think about analog now, you think about where are we going from a digital perspective. Our vision is to be a leader at the intelligent edge. And when you think about how do companies define that, many companies think about the intelligent edge as the network edge or the cloud edge. But for us, the intelligent edge is really around, converting, raw data into actionable insights. So it's really sits at the intersection of the physical and digital world, and that's our sweet spot. So that's where we do the most of our innovation. So nowadays, it's not just about the analog, it's about the analog plus the digital plus software plus security. So it's providing more of an entire solution for our customers.
Well, a lot of the world is analog, right? And I remember one of my first consulting projects. It was a medical application, but you're collecting signals from around the heart, which is analog data, converting it to digital, right? And then analyzing that. And there's still a lot of that going on, right?
Yeah, and we do that as well ourselves. Within digital healthcare, we have many products around remote health monitoring. One of them is a Sentinel product. So you probably see it on our website, whereby it really detects cardiopulmonary disease. So it's like a device that the patient can self-put on themselves. It captures data, captures arrhythmia from the heart, sends it to the cloud. We do it. We have a specialized algorithm. And it really helps the doctor to, basically diagnose and look at patient monitoring remotely, and prevents the patient from having to go to the ER or into the hospital every time. So those things are becoming a lot more prevalent in the industry for sure.
So it's like a band that you wear across the chest, and then it's recording the heart.
Correct. Yes.
Mm-hmm. Yeah. Yeah. I mean, and like most of us, right? I mean, you have some event, you go to the doctor and you're fine, right? And you're trying to catch that. And I think that monitoring actually a huge benefit. Right?
Yeah, it's like, as a patient, you're more relaxed in the home setting. You can take this reading. You don't have the increased blood pressure or, as you're going into the hospital. So it's just better care for the patient.
And it's smart, right? It's just this recording the heart data and giving it to the cardiologist, and here's, a month worth of data, right?
Yeah. And look, typically in the past, analog devices would have created the sensor. But, as I mentioned at the beginning, it's taking the analog, taking the digital, taking software, security, And even with this particular product, we've actually done all of the industrial design as well, and really looking at how do we generate services type revenue. So this is a new frontier for analog devices.
So you're not just doing the chips for the devices and the products for development of the devices, you're selling some devices now too, or is that through a partner?
Right now it's through a partner, but we really like doing co-creation with our customers. We're doing this more and more. So for us, it's not just about solving the domain-specific problem our customers have. It's really what is the experience that solves that problem too. So a lot of the skill sets in analog devices now are not necessarily design engineers or IC engineers. It's the entire package. It's UX design. It's cloud architects. So we do this, and in many ways how we do it as well is, we do have an incubator center in Limerick where we bring in customers and we co-create with them, and it's a full working environment where analog devices employees and our customers' employees have a space that they work on 9 to 5 on co-creation.
That was my next question. I mean, if I'm a startup and I want to create some device like this, what do you have to support that?
Yeah, so we have various programs. That particular one that I spoke about, it's really looking at automotive, looking at robotics, looking at unique IP that our customer might have, but they want to extend that by adding our signal processing, adding our ultra low power, the areas where we've been traditionally well known for. And how do we put that together as a package? And how do we then go to market together with that? So that's becoming more and more of an ask that we're seeing now with startups and actually with OEMs as well, and as with Fortune 500 companies. It's across the board.
Well, I mean, obviously going to Limerick would be a great place to go and fool around with some hardware. Do you have anything in the United States?
We do co-creation in our Boston office. So we call it the Analog Garage. And this is really looking at, technology that's way off out in the distance. And we do co-creation with that within that site. And we then will mature that or process that back into the business units to actually run it as a business. So some stuff that goes through that doesn't make it to fruition, but that's the idea. The idea is fail fast, repeat. And we do have some products that do graduate out of that. So that's really unique. There's a lot of stuff around the medical space as well in that particular region.
So in some ways it's like a studio.
Correct.
An accelerator.
Yeah. And it's laid out like a studio. There's no formal desks. You can build the place how you like it. We have access to all the universities locally, so it's been able to bring in people with domain expertise directly into the space.
And then you do a lot with security and performance, right?
Yeah, so security for us is job zero. When I set up my software team many years ago, I was involved in an internal sprint where we were looking at IoT and where was this going, and cloud was going to be a big piece of it. And as you partner with the cloud providers, it's a shared model, right? So, they will give you all of the tools to make sure what you build is secure, but you have to know how to use those tools. So everybody had to become a security expert. You're not just developing a function, you're not doing front end or back end. You now are responsible for making sure this device has data encryption, it's data at rest, data in transit. So security is a big piece for us. And the particular group that I'm involved in is the software and security solutions group. So we marry security with software. It's a big piece.
Yeah, I think a lot of people, think that you get a cloud instance and somehow it's secure. Oh, I've got AWS or I have Google Cloud, but it's just sitting out there. Protected. They're not really doing much, right?
Correct. Unless you protect the S3 buckets, they're open to the world. Mm-hmm. So you got to know what you're doing. Cloud is brilliant. You can scale through the cloud. There's so much you can do using managed services, which really improves time to market, removes the total cost of ownership. But you have to know what you're doing too to scale into the cloud. And that is the same for our hardware. With the Cyber Security Act now, we got to make sure that everything from the beginning has secure APIs built in as part of hardware development and software development.
And there's just been this exponential rise in hacking and cybersecurity. It's only been getting worse and worse.
Yes.
Right?
Yeah.
And then I imagine with the medical devices and really a lot of IoT devices, you don't want someone hacking your heart monitor device, right?
Absolutely not. Yeah. We have various trusted root technology. We do this in that particular product. We also do it in the electrification of cars. So we basically look at the electric footprint that's coming into the charger. We make sure that we encrypt that, and we make sure that that's coming out the other side is secure. Because there's always going to be bad actors, no matter what industry you're in. So whatever technology you're there's always someone trying to break that technology.
And is that through SDKs, or how do you approach security? If I'm a startup founder and I have an IoT device or a medical device, and I want to make sure it's secure, what should I be doing?
Yeah, so everything we started doing recently now is all SDK driven. And we have standardized on how we do embedded development. We've standardized on how we do web development. So we have secure APIs for everything that's cloud-based. And from embedded development, it's all secure SDKs built in from the ground.
Is that something you just get with the chipsets, or is something you have to...
It is, and we started leveraging a lot of open source technologies as well. So as a company, we've embraced the open source community. We've embraced the Zephyr community as well. We truly believe in Analog Devices that the software developer should own their own software pipeline. They decide when they upgrade. And for a semiconductor company, typically you would say, oh, this is IP that's locked down, it's not going to be open. But there's been a change in the industry, and it's been received very well. So we've got a lot of software developers now that talk about Analog Devices. We've seen it especially as part of the pandemic. So when we were in the pandemic, a lot of our broad market customers who didn't necessarily have access to silicon because of the supply chain issues, they really embraced reaching out to ADI and saying, we really want to continue to develop our solutions. We need access to the SDK. We need access to the APIs. We don't need the silicon right away, but we want to be able to continue innovating. So that was a light bulb moment for us where we said, okay, going forward, all projects, as much as possible, are going to be open sourced. And so that's the path that we forged forward.
Have you done anything along the lines of emulation for the hardware when you don't have the hardware, or how do you do the debugging when you don't have hardware?
Yeah. So modeling is a big piece of what we do. We do this right down at the hardware level. So we have IBIS modeling, IBIS AMI. We have SPICE modeling. We leverage our SPICE modeling a lot in the power space. But we've also recently been doing Simulink modeling, and that's what customers are looking for. They basically want you to provide a model in their tool of choice so that they can simulate the performance of the product. So that plus SDKs plus APIs has been a big game changer for us. So it's not just about, okay, let's wait until the hardware is ready and then we'll give you some software. And that's how traditionally we would have done it. So software in Analog Devices for many years was seen as an enabler. Now it's a first-class citizen with our hardware. It has changed completely. Let's
talk about scalability. That's something that you also target for your software solutions in your industries. How do you actually approach that?
Yeah, scale is a big thing for us. We really, as we build our solutions, we engineering them now from the ground up, making sure that we're leveraging an awful lot of third-party products. So as an example, if our software supply chain today, we have shipped over 45,000 open source and third-party technologies integrated into our IP. So let's not reinvent the wheel. Let's take something that others have done, build upon that. It's a big part of what we do. And even within the company itself, right? There's 25,000 employees. We're geographically dispersed across probably about 60 sites. And I can guarantee you there's someone else that is developing a similar solution to someone else in the company. So one way we scale is we decided to centralize software in the company and really put some governance and process, really build a robust software supply chain. So to make sure that as our solutions go out to customers, they have to go through this supply chain. That there's greater accuracy on our software bill of materials that we supply to customers. So there's been a big investment behind that on the tools around our supply chain to really build confidence with customers so that when they get products from ADI, they know that they're properly licensed, they don't have any security vulnerabilities, and then that we're leveraging third-party products in the right way possible. Cloud is a big piece for us too. We just spoke about that, but we have business units coming to us, and we call it skuntworks, whereas you do an MVP, and what typically happens is they now want to show that to a customer. Now they want to make it a product. I'm like, hold on, we've done an MVP. You got to pull it back to make a product out of this. It has got to go through dev, QA, production. But we started creating these generators. So a lot of the products have the same thing. That they want to take data off a device, run it through an algorithm, basically visualize that data. So the generators that we've created do this. So, we have for authentication, for data capture, whether it's streaming or batching, those kind of things. So we can typically engage with a new business unit and get data off a device into a customer's hands in pretty much under a week. It's just using reusable components.
Is that what you mean by generator, or what is a generator exactly?
Yeah, so it's a code snippet that does a particular function that is probably required in every project. As an example, how do we authenticate? So, we have a generator for that. Whether you want to authenticate through some of the social channels or whether it's just with analog devices. How do we do data capture, whether it's streaming or batching? We also integrate telemetry into all of our own solutions. And that's been a big change for us because a lot of the time for many of our legacy products and tools, we would not know who's using them, how they're using them, when they're using them. And the roadmaps were kind of being driven by the hippo effect, highest paid person in the room making the decisions. So I'm a firm believer in, product mindset, big fan of Marty Kagan. So we started integrating telemetry and really having data-driven roadmaps. So, and providing that data back to the product owners, back to the business units to say, okay, here's what the customer seems to be doing. And this would be non-PII data, so we're not capturing any GDPR data, but it really helps inform the data roadmaps because everybody has an opinion on what we should do, but you need to marry that with the real data.
As an entrepreneur, I know the importance of proactive legal advice. Hunton Andrews Kurth has been a leader for over 120 years, offering top-notch support in energy, finance, real estate, and retail. They handle problems like their own. Hunton Andrews Kurth, they get it done. We're sitting down today with Aleksandr Timofeev, who is the founder and CEO of POLYN Technology. Welcome to the show, Aleksandr.
Yes, thank you. Thank you. I'm happy to participate. So I was in Embedded World in Nuremberg.
Okay.
And now it's a good chance to meet a lot of colleagues from US.
Yeah, we are actually there too, out of our Munich office. So we're happy though to see it here in the United States. So tell me a little bit about POLYN and yourself. And you specialize in something called Nueromorphic analog signal processing. What is that?
So we try to bring new way to raw data processing, because now what happens, it's really trillions sensors around us generate like a raw data tsunami. So everybody knows how fast your memory in telephone is expired for photos. But in many industries it's a huge problem. So you have raw data coming from sensor, you need transfer this. And the initial idea, which was 20 years ago, that we move everything to cloud, not always works well. So not all data you can transfer to cloud for processing. So because it requires a lot of power, data transfer, and etc. And in many applications, you need to extract information on sensor level. And that is a problem which met industry, that if you go this direction, the digital system are not very well perform in this specific area when you need to work in ultra low power, real time, and like dirty data, which is just coming from sensors.
And a high sample rate or something like
yes,
that, right?
And the low latency and all that. That is what we're targeting, to use analog neuromorphic core, the system where data processed directly from analog sensor and in analog format without digitalization. So it's not the classical von Neumann system where you have steps of execution. It's a inference which coming an analog data propagation through physical structure, like our biological system works. So that is a fundamental idea, and we unique in a way how to deliver this, because it's a lot of discussion for last decade about how to deliver this, and I think we find a very interesting way how to build real product which is practically available with reasonable cost and can be available for that purpose. So that is voice, vibration, various low resolution image, health sensor. So it's a wide category of data can be processed this way.
So as that analog sensor is collecting the data, you're not actually storing it in ones and zeros, or how does it actually work that you're processing it at an analog level?
Yeah, for example, microphone. So the we are speaking the most microphone are analog. So you fix the acoustic wave, and that signal is analog in nature. So we did analog to digital conversion for digital processing. But if we take this analog signal, we can send it directly to neuromorphic core, which have physical neurons, 1,000 neurons. And for example, detect voice, no voice. Your microphone, it's mute if you are not talking. You come on the street in your headset in noisy area, and your counterparty don't listen noise because you are not talking. When you start talking, it detect very fast your voice and open the microphone. It can be extract voice from noise, detect command, and all of this very fast is microsecond latency and microwatt power consumption. And what is important, without connection to cloud, so no latency, so you don't need to send data to cloud and send back. So
this can happen on the device itself?
Yes, and not it's not on a device, on sensor. So you can build like integrated chips, a microphone plus small silicon which is embedded on top of microphone. So it's can avoid any resources from digital system. For example, for auto mute feature, for example, your smartphone or your headset completely off. So you are not spend resources and battery for this always on control. So only small neural net, analog neuromorphic neural net, monitoring this signal and detect voice. So that is the simplest example how it works, but it's just showed it.
So that can help with the power requirements. So essentially the whole device is off except for this little sensor that's trying to detect when you start talking.
Yes, and what is important, it's a real AI detection. It's not it's like a signal detection. It's a voice recognition. So it means they are not react for noise, for dogs, for kids, but only when you really start talking. So the AI core recognize specific voice pattern, because human voice have specific pattern. We train this neural net for detect human voice and then recognize. So that is that's exactly how it works.
And that's all happening locally, because normally that kind of thing
absolutely that is
take a lot of processing power.
Yeah, that is the benefits. You have completely offline locally without data transfer and with low latency. Typical inference time for our core is a few microseconds. And for some application, it's very critical. For voice recognition, of course, it's not for sensitive, but for example, we have few customer use our technology for 5G, 6G telecom application. In that application, for example, latency, it's a key factor. So you need process raw data very fast, half microsecond, or maybe less. And if you did this in digital, so you can imagine, so your sampling rate should be gigahertz, many gigahertz. So it's a lot of power consumption. If you did this analog neuromorphic, it's both. It's low latency and low power.
You've already implemented this on shipping products?
First shipping product will be available January. Now it's in production. We tape out, because we built not only product, we also built a platform. So it's a technology platform, like ecosystem, which can convert digital model. So our source, it's a digital neural net model. And then we automatically convert this to analog neuromorphic core. And it takes time for us, so a couple years, to build this whole platform. It's a specific compiler working in top of Cadence ecosystem. Now it's done, and the first product chip in tape out. And then next product we can launch very fast. It takes approximately a month to generate new layout for next chip.
Is this product voice related or is it something else?
We have a 3 line now. First line, it's a voice related. Yes, it's voice recognition, command detection, voice extraction, so that set of command for remote control and etc. Second line, it's vibration, accelerometer data. For smart tires, it's our first big market for
smart tires.
Yes, it's a specific sensor which integrated inside the tire, inside the rubber.
More than just pressure.
Yes, it's add on to temperature and pressure monitoring. Now the standard is in temperature and pressure monitoring, which is mandatory for many countries. And we built chip which integrated together with standard TPM sensor and can detect various events, for example, road condition changing, which is now it's specifically important for autonomous driving. If you push your car to autopilot, it's very important for system to know, for example, that the road is changing. You come to wet road, for example, because friction coefficient it's changing. The simplest the adaptive cruise control, the distance should be different for wet and dry.
You can tell that. I mean, the sensor, I imagine, is inside the tire.
Yes.
How do you detect that it's actually wet outside?
Because when you drive, you listen what is the noise of your tire. You can extract this.
Sounds different.
That's
true.
And vibration is different. So, and you can extract this information from vibration. Any specific surfaces, they have a different.
You could tell you're driving on the freeway, for example, and it's very smooth and different kind of.
Or you can detect imbalance of your wheel in early stage when you are not feel this, but we can detect this. Or wheel bolt release, so that is a lot of event can be detected in very early stage. But the first one is friction control, which is important for now for autonomous system, which is more and more coming. And the only one way to detect this directly is listen vibration from point of control or contact where wheel is coming. And here it's a barrier again, latency and power. Because this sensor should be integrated inside the tire and work few years in one battery. If your battery is dry and you are not change tire just to replace the battery. And that is the biggest barrier for implementation of this. And so we solve this problem. That is our second line. And the third one is wearables.
Wearables?
Yes, it's a sensor for heart rate and
heart rate
monitoring, SpO2 monitoring,
pulse ox,
and the people movement monitoring, and all of that specifically for continuous health monitoring for people to convert smartwatches to real. It's not medical device, but it's like advisory. We call this a medical AI advisory.
At Softtek, we don't just follow the trends, we set them. As the founder and CEO, I've built a team that excels in delivering cutting-edge solutions in software, hardware, and IoT. From concept to completion, we're the partner that turns your tech dreams into reality. Softtek, where innovation starts. I'm sitting down with Weier Wan, who is the founding member of AIZIP.
Yeah, thank you for having me, Chris.
Absolutely. So what is AIZIP?
So AIZIP is a AI software company, and when people talk about AI, they typically think about OpenAI, Google, or NVIDIA. So those are the companies who are providing those gigantic AI models, very powerful, running on the cloud. Whereas AIZIP is really focusing on the other end of the spectrum, right? So we make very tiny and efficient AI models that are running directly on your devices, right? So these devices could be a smartphone, right? But it can also be a even smaller embedded IoT devices, like a sensor in a factory, or your smartwatches, your smart earbuds. So essentially, our goal is really to make everything think and make AI broadly available to everyone.
Well, why do you need AI on a sensor?
Yeah, that's a great question, right? So I think having AI locally on the devices bring a lot of benefits, right? So for the end users, apparently those data are being generated at the sensors, right? So whether it's a camera sensor, image sensor, a microphone, or it's a health monitor that monitor your vital signs, right? So those private data, you don't really want to send all of them to the cloud, right? So data privacy is definitely a big concern for a lot of users, and also for a lot of real-time applications, like if you're doing computational photography, or you're doing denoising in your earbuds, just the latency of sending the data all the way to the cloud and back, those are just too long for these real-time applications, right? But at the same time, for the service providers and the device makers, I think it can save a tremendous amount of operating cost for them by eliminating the need for very expensive cloud AI subscription, or hosting AI on the GPU cloud. So those are all the benefits of having AI right on the next to the sensor on the edge devices. I would say these edge AI models doesn't work by its own. So in the end, I think the whole AI application is really part of it gonna be on the device and part of it gonna be on the cloud, right? So taking your example, you could be doing person detection or vehicle detection right on your camera, right? And then essentially that help you to focus on this interesting clip within your video, and then you only need to send that small clip to the cloud for the more complicated video understanding and more complex insight generations. So this way the whole end-to-end pipeline becomes much more efficient and effective.
Yeah, I can really see a need for that. Besides video, you have audio, like you said, noise cancellation, but other things, some type of noise detection, wake words, things
That's
like
right.
that you want to wake up the device so that you can be more power efficient, more data efficient, less latency.
Exactly.
But weren't we doing some of this before and just not calling it AI?
Right. So I would say, for example, the noise cancellation, right? So there has been DSP-based noise cancellation technology for generations, right? But AI, I think, really bringing new capabilities and enabling new features, right? So one thing that we heard a lot from our customers who produce audio-related products is that the traditional DSP-based technology, like beamforming, so they're very good at canceling steady noise, right? So let's say if it's a constant noise in a background,
like an airplane or something.
Exactly. Yeah. I think the traditional technology are perfect, right? But now maybe you've seen the commercial from Apple talking about like adaptive audio experiences. So essentially you're working on a Austin street and there's a lot of construction going on, and your AI model now can actually differentiate the construction noise from a vehicle behind you is horning, and you don't want to cancel that out, right? So essentially now the noise cancellation can be more adaptive, right? And also, it is better at canceling non-steady noises, right? So for example, if you're wearing a bike helmet and there's very like strong wind noises, but it could be very loud and sometimes it's lighter. For those scenarios, we found the AI algorithm-based approach significantly outperform the traditional methods.
It's using AI to vary the level of noise detection, noise reduction, or how it's actually helping to reduce the noise, right?
Yes.
I guess another scenario would be like if you're in steady state and you whack a hammer on something, that's going to be very sharp.
Exactly. So one very interesting case that we work on was a gunshot, right? So I mean, it's so that one was really to showcasing the capability of our model. So we found some video of like a battlefield, and we play some like human speech in front of that. And our model can be so low latency such that even a short burst of like a gunshot can be almost completely eliminated
in real time.
Wow.
Yeah. And then you just leave the verbal audio.
Exactly.
So you can actually understand the person even though this gunshot happened.
Yes.
Earmuffs just drown out everything. Right?
Yeah.
The headset, right? But with this, you could be wearing like an AirPod that is really only going to kick in during the gunshot.
Yeah, that's right.
Fast.
Yeah, I mean the application space is vast. So apparently, like earbuds is one that everybody use, but it could also be used in, let's say, like helmet, right, and in cabin of automotives. Many different places. So essentially, whenever you want to talk to someone in a phone and you don't want the person on the other hand to hear all the noises behind you. And our model will be able to do that.
It seems that in most cases, without that technology, the opposite actually happens because these microphones are so good. The guy comes to mow your lawn. It's not that loud to you, but for them, somehow it's actually amplifying the noise instead of suppressing the noise.
Exactly, yeah. Mm-hmm. So I think, the way I see it is, so the fundamental hardware technology, like a better MEMS microphone, it really opens up all the possibilities, picking up all the sounds near you. And then what AI and software does is, based on the specific application demand, you can tailor which sound you actually want to pass through your communication channel and let people hear. Mm-hmm. Yeah.
I think I need that. Well, tell me a little bit about this article that you wrote recently that actually got a lot of attention. What was that on?
Yeah, so lately we've spent a lot of effort developing these on-device small language models and AI agents powered by that, and we believe it will really enable the next generation personal assistants on a wide range of devices like smart glasses, like like a smart cockpit and smartphones, and really the idea is that the traditional voice assistants can only do limited hard-coded things, right? Whereas using the small language model, which I think you know it, you probably know this very well from like using GPT. It has this ability to reason and to make plan, and so now it is able to understand more complex intent from user, and then decide what tools it should use, right? So the tool could be, let's say, if I ask a math problem, right? So it could decide to use a calculator, or I'm asking about the real-time weather, so it could help me to check weather, right? And also it is able to be very personalized, right? So I think traditional voice assistant, it doesn't really sound like a human, right? So it's very robotic. It always give you a fixed responses. Whereas now, so let's say I'm asking, I'm traveling to Austin this week, and what should I be wearing, right? So it can first decide to check the weather, and then just tell me, this week is pretty hot and pretty sunny, so you should bring light clothes with sunglasses. Yeah. So essentially, all the responsive style, the tones, and the content can be tailored specifically to you and to the questions that you ask.
Can you do that at the edge, or do you need the cloud for that?
Right. So today, so these kind of capabilities are only possible on a cloud, right? So assuming you're using like a large language model from OpenAI, from Anthropic. So what we're doing is we try to really put the GPT level intelligence right on your fingertip, right? So those big cloud models, each of them have maybe like 100 billions or even trillion parameters. And if you look at the device, like your smartphone, right? So the biggest AI model that you can reasonably put on it is probably a few billion parameters. So there's a 2 orders of a magnitude difference in the model size, right? So essentially that will translate to a difference in their performance, right? So now you can imagine, with a small language model, perhaps the generation quality is not as good. It's not as versatile as a large language model, but so we think really in order to get all the benefit of being on device while not suffering from this performance gap, performance loss, is by being very domain specific and task specific, right? So while maybe a small model cannot be able to generalize on a wide variety of tasks as well as large language models, but you can actually train it to specialize in specific tasks and do it as well, right? So lately we released Gizmo, which is our small language models and agent. So they are really trained to specialize in everyday on-device tasks, right? And we've benchmarked that across a variety of on-device tasks, such as using tools and answering questions related to a user manual. And on those specific tasks, Gizmo can perform as well as the biggest state-of-the-art large language models.
Basically training it on a smaller subset, like a manual, for example. It only needs to know the manual.
Exactly.
Doesn't need to know anything about, history.
Yes.
Speaking of history, I think that's one thing also that these models, first of all, AI already needs so much power and so much data, but you start over with that model. So it's like that movie Memento, where the guy only has short-term memory, and you kind of watch the movie in reverse, so you kind of can feel what it was like for him not to know what was going on. AI, just every time you ask it a question, like an Alexa or Siri, she's like starting from scratch, right?
Right.
She doesn't know you at all, doesn't take into account the 20 times you asked a similar question.
Exactly.
What songs you like to play. Like, why are you playing me rap music now? I've never asked you to play rap music.
Yeah.
I'm trying to play this pop song over here. Right?
Yeah.
Are we going to get there at some point to where the agents actually have memory?
One very important part of being personalized is having memory about you, right? And this is something we actually developed for the Gizmo AI agent, right? So let's say I told Gizmo, my workout routine lately, and it was, and I can just ask Gizmo, I've been sticking to this workout routine for a while. So what do you think I should improve, right? And the Gizmo can tell me, you seem to be running 3 times a week. How about adding some weight training, right? So it will have the memory of you. And we believe that that's a very important part to make these AI agents more human-like.
I know how important staying informed is for innovation and growth. The Forging the Future newsletter brings you the best in tech trends, startup advice, and industry insights. Join our community and forge your future with us. Subscribe now. Sitting down with Martin Unverdorben, and he is the Technical Information Manager at Tria, formerly known as Avnet Embedded.
Thanks for having me. It's a great pleasure for me being here.
Thanks for coming. Sounds like you're also a fellow electronic engineer.
I am by education. I'm an electronic engineer. That's
hardware
right.
guy.
I'm a hardware guy deeply. So sorry, I don't like the software really much, but yeah.
There's some reason there's a lot of embedded hardware guys walking around the show here. So what does Tria do?
Tria is formerly Avnet Embedded, formerly MSC. So a German-based company which was acquired a few years ago by Avnet, and we are doing computer on modules and also custom designs for In all verticals, and we are very focused on standardized computer-on modules. So we are members of PICMG and SGET. So these are some standardization consortiums. I'm also very into SGET, especially. I'm a member of the board there. I'm the chairman of the SMARC standard development team to bring further these standards. And yeah, sometimes you have to cooperate with your competition because it makes the world a better place.
Yes, collaboration is key. What is SGET?
SGET is the standardization group for embedded technologies. It was founded in 2012 to be a host for SMARC and for Q7, which were the very first standards there. We are a German organization, and the reason for SGET was there is already another organization, that's the PICMG. PICMG is great if you want to have very deeply sophisticated standards. What we needed there in 2012 was a fast solution. And that was the reason that SGET was created, because we could set the rules a little bit different to get it faster on the road.
And Avnet is of course a well-known supplier of electronic components, and so they acquired a company, and it was Avnet Embedded, and this is for like more embedded services, or creating system on modules, or
these computer on modules, exactly.
Computer on modules.
Yeah, you can call them system on modules. You can call them compute.
COM or SOM.
For a few weeks ago, I asked ChatGPT if they see a difference between that, and they thought though, but I don't see that. So I'm not sure if the feedback I gave ChatGPT will make a better answer out of that. I don't think there is a difference. It's just the different name for the different thing, and some companies call it SOM, some companies call it COM, and some even call it compute modules. So it's.
Have you tried telling ChatGPT when it's wrong or giving it other information?
I try, but I'm not sure if it works.
I have had it thank me for correcting. I don't know if it actually goes into the memory pool or not. So what key steps do you recommend for transitioning from a low power or POC to a market-ready product?
Whenever you build an electronic device, you have 3 different ways of how you do that. So one is that you put something out of the box, connect it together, and you have a system, maybe make a housing around, so a Raspberry Pi, a main board, motherboard, whatever, maker board. Typically, you can do that for low volume sizes or for just getting a POC, something. That's the idea of it. On the other side, you can do a full custom design, which means you take the chip, you take the CPU, the RAM, all the IOs you need, make your own PCB out of it, make your own software around it, your own firmware for it. It's a more cumbersome way. It's the other end of the spectrum. And a computer on module is the compromise between. So whenever you ask the FAEs of the CPU manufacturers, and it doesn't matter if that is Intel, NXP, Renesas, TI, or whoever, any FAE, and you ask him the question, what's the most critical interface on your CPU, and all of them will tell you it's the memory. They will get most questions about the memory, and whatever module you are choosing, memory is already there, so the most problematic interface is already covered.
As part of that solution.
As part of that solution, and you can do your carrier board on your own, and with that you have the flexibility that you need. But still, you can buy just one component instead of 900.
So it's speed to market.
It's faster, definitely. It is faster. And for these computer on modules or system on modules, there are 2 different ways out in the market. One is standardized ones, and the other is proprietary ones. There are some companies there who take an SoC and make a a module out of it by just bringing all the interfaces out as best as possible. It's, in my opinion, a worthwhile try, but in my opinion, it's not the best one, because by doing this on a standardized way, you offer something to the customer which he won't get when it's proprietary, because he can use a second source for it. And that's quite important because we are building the hearts of other applications. It's the dear core of a big application that might be in the market for 20, maybe 30 years. And if you are a customer would not want to be bound on a certain vendor if not necessary. And that was the original idea of standardization.
How do you determine the viability of a POC before moving to the product development phase?
Well, you need to know your market. That's the very first thing. Knowledge is the key here. I had a very nice example in my session at the Embedded World here, and I explained a little bit about somebody who created a POC as a intelligent cat flap. So, yeah, you have somebody has a cat, and the problem is the cat comes into the house and brings sometimes gifts that you do not want. So he created a Raspberry Pi with a camera and an RFID chip connected on a solenoid lock to lock the flap. And
if it detected the cat had something in its mouth,
exactly. There's some NPU, TPU connected to it, and if the camera sees the cat with something in the mouth, it will close the door. So that's nice. There are also applications out there. It was just an example, but what you need to know first is how big is your market. So, I mean, you can easily find out that there are millions, I think 45 million cats in the US, for example. You can research that, but you won't not be able to research how many of these households have the same problem and how many they want to pay for it. So you need to know that. You need to find out. You can do your own research by setting up some advertisement and some forms to get information for that. It's easy. Or you do some crowdfunding campaigns. Because with that, you get knowledge about it. You also get money for it.
And votes, basically.
Exactly. And you have to deliver at least a working prototype that can be sold. So if you are a startup, that would be one of my ways I would go.
Yeah, I think Kickstarter and some of those platforms have been great for testing out the market.
Exactly.
Sometimes they get overwhelmed and they get
of course.
a million orders or whatever, and that's
there's
a whole
also
different problem.
A lot of stuff that might not be successful there, but there were also quite great stories there.
You know, ideally what you want is like a modestly successful Kickstarter that allows you to do version 1 and kind of learn all the things you don't know yet about production. Hardware production is definitely a different animal. Yeah,
and during that process, you for sure have to go with certain iterations. Yeah, you have to define your requirements, maybe redefine later on your requirements. You have to check your prototype against it. Check it maybe also on a target audience. And then if that will not work out, go back. And if it works out in the end, you can sell your product.
Is there a large community of embedded products and development in Germany?
Oh yeah, there is. Yeah.
The Embedded World Show, of course, originated in Germany. You're located there.
Yeah.
There's quite a few others there. It seems to be a local area.
Yeah, it is all centralized in a small town called Deggendorf, northeast of Munich, where it started with a company called Jumptech. I started there in the year 2000. Jumptech became Contron. There was a spin-off of Congatech there, and also FNet Embedded Tria has an office there. So
if startups aren't your primary client, I mean, what type of companies come to you for development?
All of them. All Fortune 500, all of them, really. Really.
And they'll come to you with, hey, do they bring their POC, or they come from like, hey, we have an idea?
most of them have a problem and they are searching for the best way to solve that.
I see. So it is starting from a requirements doc.
Exactly.
And then you create the whole product end to end and do
It depends completely. So we have customers doing their own carrier board, doing their own system completely on their own to just buy the module. But we also have customers who want to get everything from us, and also that is possible. As we at Tria have our own production, so electronic production and also system production. So we have in Stutensee our electronic production, and in Eschbach near Freiburg our system production. Brand new, really an incredible building there. Really impressive to see that. And there we do a system production. That's really great what we can do there.
Is the timeline for this product development, is it slowing down or speeding up with the complexity that we have?
With modules, you can speed it up because you just need to create the carrier board, and with that, it's much easier than a full custom design, of course. Yeah.
And you're creating everything from IoT to do you do any wearables development?
Not sure about that, because wearables with modules might be not the best choice. Mm-hmm. So when I'm just into the modules, so I can't answer that. There might be that there is something somewhere now from our system colleagues doing something with wearables, but I don't know.
Do you see any market trends that are influencing the design and development of these low power solutions?
Well, the biggest thing, the biggest disruptive thing was the beginning of the maker boards years ago, because they brought the knowledge into the market by giving a Raspberry Pi to every new student. That was great, in my opinion, to do that. And also it brought a heavy price pressure into it. So I think it's good because it will increase the competition. Yeah, because you have to be better than the others to be in the market.
So low-priced platforms and also early education.
Of course, education is key. Mm-hmm. Yeah, because you need to know how to do it to avoid problems. Yeah, and you said startups before, but also big companies can fail on lack of knowledge. So. I can give you a story that I had in my history as a field application engineer. More than 15 years ago, a big customer from the medical field, I don't say any names about it, but one of the big five, and they created a cardio ultrasonic device. So that doctors use to get your heart checked. And this was developed with one of our computer on modules as the human-machine interface. And they asked some questions during the process. And when they had the first prototype, they said, "Oh, we have so strange issues. Can you help us?" We got a system from them and we could check it. It was an ultrasonic device. That means there's a lot of digital stuff in it and there's also a lot of analog stuff in it. And one of the main rules when you have a mixed system is that you split the grounds. And they didn't do that.
You split the grounds, yeah.
Yeah, that you do not get interference between analog and digital, yeah, because with the ground planes, it could happen that there's a lot of interference between. So what they saw, for example, is there was disturbance on the monitor. Also, it was unstable completely, the system. So unrecognizable reboots happened.
So a rookie mistake.
Absolutely rookie mistake, and this was one of the biggest companies there, really, due to lack of knowledge.
Well, the secret on the big companies is that you soon learn that the company is big, but the teams are just a small startup, essentially, running inside of a bigger beast. And then often the challenges can be that team maybe doesn't even have the entrepreneurial background to actually ship a product.
Yeah,
right?
but then I would assume that there is some kind of supervision integrated, and somebody needs to look over that, at least over the blueprints. It would just be enough to take a look on the block diagram, maybe, or at latest on the schematic would be.
hey, this is the power of bringing in third-party partners, right?
Exactly, and also to get more knowledge or create or get more education onto that. That's necessary, yeah.
So what developments in embedded computing are you excited to see on the horizon?
Well,
what's in the future? That's what I'm really asking.
AI will make a big difference, in my opinion. It took quite long until you saw really applications coming up, but now, mostly based on some vision detection stuff, it's coming up right now, and that really will change quite a lot. I'm quite sure about that.
When you say applications, what do you mean?
Yeah, for example, intelligent lawnmowers, something like that. Yeah, or autonomous vehicles wherever. So it can be just forklifts in warehouses. Yeah, this is something that will come up.
The influence of edge AI, essentially, right?
Exactly. And these will be the applications, and I'm quite curious about them.
Me too. I think it's going to be really interesting to see what these products are evolving to in the next 10 years. Well, thank you, Martin. It's been a very interesting conversation. And thanks for everything you're doing to help forge the future in embedded.
Thanks a lot.